Hello students, the next topic is Bernoulli equation. A Bernoulli equation is a nonlinear equation that looks like this. Y prime plus ry, so far so good, but we have y to the nth power here. When n is 0, this is linear, but n is non-zero, now we have Bernoulli equation. And this kind of equation can be reduced into a linear equation through appropriate substitution. How do you do that? The first step is to divide by y to the nth power. Well, the first step is to get the standard form first, okay? Once you get the standard form like this, and then divide by y to the nth power, and you're going to get this. So nothing here on the right-hand side, and then we have y to negative nth power times y prime here, and then y to the 1 minus nth power there. And then we're going to take appropriate substitution, and we're going to take z as this one. Or it doesn't have to be z, any other character will do, but z is okay. This one, which I'm highlighting in red. And then what do we do? Well, this is differential equation, so you have to take the derivative, right? So let's take the derivative. What is z prime? By chain rule, 1 minus n y to the, let's subtract 1 from the power, 1 minus n minus 1, which is equivalent to just minus 1 power, minus n power. All right? And then by chain rule, we have to multiply the derivative of the inside. Now, have you seen this before? Yes, it's right here. Here's the detail. So if you take the derivative, you get this y to the negative nth power times y prime, and then you can substitute that part through this, put it in, and then I'm going to get a linear differential equation of z like this. So we have coefficient times z prime, and then we have coefficient times z, and the right hand side is g of t. And then you can do this method of integrating factor after setting this one into standard form. Well, you can divide this one away and then get into this form. Now, this is p of t, and that's f of t, and then you can apply this method of integrating factor. Once you do that and you can solve for z, then you can always go back to this and retrieve what y is, because y is gonna be z to the 1 over 1 minus n power. So it's going to be a radical. Or equivalently speaking, 1 over z to the n minus first power. Yeah, that looks a little bit better. Okay, all right. There's a theory, but it was too symbolic, so it may have been a bit difficult to follow. So let's go to a concrete problem and see how it behaves. Here's a nice problem, and initial value problem version. And here's another problem, and it's addendum, IVT. So let's go to this one. I don't know if I'll have time to do both of them, but let's try anyway. So is this a Bernoulli equation? Yes, it is. Do you see this y second power here? So the very first thing you should do is to divide by y squared. So t y prime y to the negative second power minus 1 plus t y to the negative first power is equal to negative t. All right? Negative second power, negative first power, nothing. Negative nth power, negative n minus 1 power, and then 0 power. That's the structure. And then what substitution do you take? This one, which I'm highlighting in red, that's my z. And therefore, y is gonna be 1 over z. I'll keep this one for later use. Okay, z equals to y to the negative first power. So what is z prime? By chain rule, you calculate it negative y to the negative second power. So far so good, but by chain rule, you have to multiply by y prime, the derivative of the inside. And then do you see this? Y to negative second power times y prime. Do you see this here? It's right here. It has to show up. Let's move it over here. Okay, all right. Are we ready to plug everything back in? Okay, this is my equation. That's my equation I have so far. Okay, over here. And then this is equal to what? Negative z prime? Yeah, we need negative sign here. So this is negative z prime. And then this is z. And then, okay, that's all set already. And then let's solve this equation. Looks like I can divide everything by negative t and then make it into the standard form. So I have z prime plus dividing by t, 1 over t plus 1 z equals to 1. Looks like I'm getting this equation. Let's see. Negative, negative, negative. We can reduce all those into positive. And then divide each term by t, and we get this, and then we have the standard form. And then you can apply the integrating factor method, solve for z, and once you get z, you can retrieve y from here. But I'd like to save some time. Do you recognize this problem? Have you seen it somewhere? Well, if you already studied, then you must remember. Yes, we have seen it. It's right here. It's this problem. The standard form is this one. Yes, we have seen it. And I even used the character z to help you out further. So, okay, you can go through with the same method and get all these, but I'd like to save time. We already studied this part, so let's suppose you can do that. And let me just copy and paste the answer here. So z of t is this, and we have fractions, so I need bigger font. And therefore, y of t is 1 over z, or z to the negative first power. So it's going to be 1 over this thing. And that's a solution, and I'll accept it, but, well, just for the looks, let's take just a little bit of simplification. Multiply each fraction here by te to the t power. And then te to the t power. And then multiply by t to the t power. The t part will cancel out. So e to the t part only here. And then plus c. And There goes my final answer. Shall we check? Oops. Y of t is equals to t times e to the t power over t times e to the t power minus e to the t power plus c. Okay, and then let's put this one in. Simplify t times y prime of t minus 1 plus t y of t plus t times y squared. After flipping this one to the other side. Shall we check? Yes, indeed. That's 0. Do we have enough time for the next problem? I guess so. This one is going to be just IVP, so no problem there. Let's go to this problem. Okay, we have a solution. We have a problem here. We have a differential equation. And it's not completely clear whether this is a Bernoulli equation at this moment because this is not written in the standard form. Y prime is here and I don't know. So let's break off the parentheses and see if this is a Bernoulli equation. So, okay, let's copy and paste this thing and then break up the right hand side. So 2ty to the 4th power minus 2ty. That's it, isn't it? Okay, it looks better now, and I can now clearly see this is Bernoulli. Flip this one to the other side. Flip this last term to the other side. Then I have what? Plus 2ty. And then look at this. Is this Bernoulli equation? Y prime y and y to the nth power. Oh yes, it is. We're in business. Okay, all right. Let's go ahead with the step 1 of Bernoulli equation problem. So far it was just a setup. Step 1, what is it? Divide by y to the 4th power so that we get to just t part in the right hand side. So let's do that. Y to the negative 4th power here. And this is going to be to the negative 3rd power because I just divided by y to the 4th power. And here we go. What do you do next? What do you substitute? After this, you should be able to see it. Do you see? This one right here. Which I'm highlighting in red right now. That's your z. Okay? Z is equal to y to the negative 3rd power. So y is equal to 1 over z to the 1/3 power over queuing root. So that's the substitution I'm going to do. And then I can retrieve y like this. Okay, and then this is differential equation, so you'll have to take derivative. And yes, you have to do this right here. Take the derivative. Z prime is equal to negative 3y to the subtract 1 from the power, so we have negative 4th power. But that's not complete. By chain rule, you need y prime. And this one, have you seen this before? Yes, it is, right here. And as for this constant, negative 3, we can always work it out, divide by negative 3. So that's not really a key issue, but in this particular case, we already have 3 here. So everything really looks good here. So substitute everything in, what do you get? We have this negative sign, so we do need negative 3. Negative plus t squared z prime plus 2t z is equal to 2t, and there goes your first order linear differential equation. And you can use the method of integrating factor to solve it, but before that, of course, you'll have to change it into the standard form. Divide everything by this leading coefficient, and it's a prime minus 2t divided by 1 plus t squared z equals to 2t, but I have to divide by negative of 1 plus t squared, so I need negative sign here. And there's fractions, so let me explain once so that I can see this thing better. Let's see. Let's look at the second equation. Too much space. It's a little bit hard to read. Now, look at the second equation here. Do you recognize it? Have you seen it before? If you don't recognize it, you have to solve it now using the method of integrating factor or whatever. If you do recognize, where is it? Tell me. It's right here. It's this problem. The standard form here, after dividing by this leading coefficient, is right here, this one. No, this one right here. And that's the very same problem we are looking at here. So we have done it before. If you haven't done it before, then you have to take a deep breath and then you have to start over and get this first order linear equation problem done using the method of integrating factor. But I'd like to take time. So what is the solution here? That's the solution. I'll just copy and paste that, assuming that everybody can do this. So y of t is equal to 1 over cubing root of this thing. Now this doesn't really look good. I don't like cubing root very much after writing everything here. So let me go back to this power form again. Okay, let's go back to negative 1/3 power. Okay, all right. I have the solution, so let's check. Y of t is this. Okay, and then here we go, that's the equation, so simplify. And then the left hand side, 3, 1 plus t squared y prime of t, minus the right hand side, 2t times y of t cubed minus 1. Did I get everything right? Left hand side minus right hand side. This should work. Yes, it did. We have the solution. So if I write a Bernoulli problem here in exams or something like that, because of the time, it is unlikely that you're going to see a problem completely new. There's high chance that you have done it before in previous parts so that you can recycle it. But of course, if I write this kind of problem in project or homework or take home, in that case, it can be really long.